Okay, 1/6. This lesson is 1 day. If you have already looked at it, it is 8 slides.
7.
2, 4, 6. Well,
Maybe do a practice question.
my thing says 8 slides. I know one of them is the homework. It's like a homework tip. Did I give you that on the end of yours? No. All right. This is a very short lesson. It involves solving linear inequalities. We are looking at linear, which means you only have the variable x. You should know this. The college level aspect comes when you start throwing it into word problems. Also, the college level is having ugly answers and not being uncomfortable with ugly answers because you're at the college level. Before we dive into the lesson, I do want to remind you, if you multiply or divide by a negative number, on both sides, of an inequality, then you have to flip the sign. Don't remember what this means. I'll show you. I'm going to move. Hold on. No, I'm in the way. I don't know why that's there. Alright. So write that down and then put the examples at the top. Let's refresh your memory with the basic. So I know you already remember this. It's probably one of those sleeper concepts that is in the back of your mind, but it doesn't come up a lot, so you probably forgot about it. And we're like, oh yeah, I remember that. But the problem is I've found that people forget when they're to pay attention to when it's actually the negative number that's moving to the other side, when it entails flipping the inequality sign. I've seen people take something like this, I didn't mean to, and flip the sign because they're dividing and there's a negative. They just look for those two things to check off. But what's actually moving in this one right here? It's a positive 4 that's actually moving. So there's no sign change. Whereas over here, it's the negative 4. This is the one. Red, I do. Red flag to tell you, watch out. X would be greater than -2. You're going to have to flip the sign. So, be careful there. Make sure you're paying attention to if it's the negative number that's moving to the other side by multiplication or division, that's when you flip the sign. Otherwise, leave the sign alone. All right. Go to the first slide. What's the purpose of inequalities? Inequalities are when there is an infinite set of solutions and we don't have time to sit down and graph all of them, list all of them. You can't possibly do that because it's going either towards infinity or negative infinity, or it's between a set of numbers. So that's why inequalities are important, because it lets us write the answer and encompass all the answers by showing a direction of shading. If you look at this first one, it says solve the inequality, then graph the solution set. All you need to remember is that watch out if you're moving a negative by multiplication or division, you have to flip the sign. Everything else is what you already do when you're basically solving equations. So let's look at the first one. We've got 3x minus 5 is less than 6 minus 2x. I'm going to bring the x's over. And I get 5x minus 5 is less than 6. I'm going to add the 5 to the right. I'm showing my work so you can see. Then I'm going to divide by the 5. And I'm going to leave it as 11 over 5 and then go to my calculator and see if it's a pretty decimal. 11 divided by 5. I think it's 2.2. Somebody can confirm that. You can't possibly graph 11 over 5 on a number line and know where to put the point unless you change it to a mixed fraction. So you got your whole part and then your fraction part, or you can convert it to a decimal to just get an idea of where it lands. So it's going to land at 2.2. Now it's telling us we need to shade less than 2.2. So find 2.2. You can either do an open circle or you can do a parentheses, and it is arbitrary. You're just drawing it between 2 and 3, and we're shading less than. Now you probably know where this is going, which is why we practiced in the Chapter R review. You need to write this in interval notation. Well, label what you shaded. This is negative infinity. Don't label this as a decimal. Go back to that fraction. This was 11 over 5. So my interval notation solution would be, read it from left to right, negative infinity up to 11 over 5, and it would be parentheses. And although that looks like a coordinate point, that is an interval notation showing you what is shaded. On my math lab, I believe it's going to be fractions. So be ready to type that. Would it be wrong to do 2.2? No. It's just the formatting of my math lab. Y'all try B. So I moved negative 7x to the right. I did that because I knew that it would keep the coefficient of x positive. You don't have to do that. I'll show you over here if you had gone to the left what it would look like. Since I did take my variable to the right, I need my constants to the left. This probably feels backwards having the x on the other side, and I agree it is. But just solve it first, then you can mirror image the whole thing. So if I divide by 17, I get 1. Notice I've not had to deal with any negative by multiplication or division. But that is hard to interpret. I would strongly recommend mirror imaging the entire expression so that your variable is on the left because you need to read it from the variable. So I'm going to draw like a dotted line to represent where I am mirror imaging the whole thing. Now, when you do that, when you're mirror imaging the entire expression, you don't have to change anything about it. Like, you're just basically the reflection. So now I can clearly see, okay, I'm going to shade less than or equal to 1. That would be a bracket or a closed circle. And then I'm going to label so I'll know how to write it in interval notation from left to right. It would look like that. Okay, had you moved the 10x to the left, I'm going to say or dot dot dot, you would have had this. Then I would subtract 13. And then because that's a negative 17 moving by division, I'm going to change so it sticks out. And then I'm going to draw right here like an exclamation point. And you can see that it's the exact same answer. Okay? Let's say I gave you a really complicated one and you're worried that you got it wrong. What could you do? Well, if I give you an equation and you solve it, what's your safety net for checking it? If it's just a regular equation, you just plug your answer in, right? Same concept applies here. You would just pick a number from where you shaded. Pick a number from where you shaded and plug it into the original and make sure it's true. And if it's true, then you shade it in the correct spot. If it's false, either you plugged it in wrong, or you read it wrong, or you did the math wrong. Okay? So like 0, I love testing 0. It's so easy to test. 0's in my shaded spot. If I plug 0 in here, those x terms disappear, and I have 13 is greater than or equal to negative 4. I can check that really quickly in my head. That's true. So don't feel like it's an inequality. You can't check it. You actually can. And you can't possibly check every number, but you can pick a number in your shaded section or even in your non-shaded and see if it's false. That makes sense because you didn't shade it. All right, go to the next one. Woo! We've not done these in a minute. Find the domain. Do you remember? See if you can do it. This is chapter R. And then we did it a little, I think, in 1.1. See if you can remember. I'll give you a hint. Going back to what we talked about. You ask yourself, what's the restriction? What's not allowed? All right, try both of them. specifically, let's just say it's an even root. Remember that? What's the rule in math with even roots? Can't have negative radicand. Helps to know the word. You can't have a negative radicand. Radicand means the stuff under that even root. It cannot be negative because you can't take the square root of a negative because then you've crossed into the imaginary world. So if it cannot be negative, you have to remind yourself, what can it be? It can be positive or it can be zero. Zero's allowed, positive's allowed, negative is not. So we're going to go from what is allowed aspect. We're going to set the radicand, you should remember this, we're going to set the radicand greater than or equal to 0 and solve it. And that's our domain. That tells us what numbers are allowed to be plugged in, because no matter what comes out of that, would keep it either at 0 or positive. So that would be x minus 6 is greater than or equal to 0, and you would solve that. So x has to stay greater than or equal to 6, sorry. Does that make sense? But let's write it. Let's write it in set theory or interval notation. You might be able to go straight to the interval notation now that you've reminded yourself how to shade. This would mean start at what? 6 and go what direction? This is saying start at 6. You can include 6 and go to positive infinity. If you need to see that number line, then just graph it real quick. It starts at 6, closed circle, and it goes this way. So that's how we determined it. The set theory that we practiced was that it's any number x. I'll put this too close. As long as x is from the reals and can't be what? Or has to stay what? Positive. I'm thinking of the other. X has to stay greater than or equal to 6. I was thinking of the domain of a fraction where the x is off limits. When you're talking about what x is allowed, you would just say what's allowed. It's the domain of a fraction where you have to say, like any real number and x cannot be something.
So it's that if you're excluding like the values.
Yeah. This is an infinite set of numbers in a certain direction, so we would just say what the inequality is. What changes in B?
You can't have 0 at the bottom.
There's a difference here. We can't have 0 in the bottom. There's a little bit more. There you go. So this one's different because I've thrown an even root into the bottom of a fraction, right? So we have, first of all, a fraction. That's a problem. There's a rule in math with fractions. We also have an even root. That's another problem. So what's the rule in math with fractions?
You can't divide by 0.
Can't have denom, I'm going to abbreviate, denom equal to 0. Can't have the denominator equal to 0. That's the rule with fractions. And then the rule with even roots, I'm going to write it again. We've already written it once. Can't have negative radicand. What I'm writing there by saying can't have this, can't have that. Oh my gosh, that hurts. No, you're good. Just gotta walk it out.
I'll pick up my phone.
Yeah, please eat your crap next time. I'm a little rusty. Yeah. The what I'm writing can't have denominator denominator equals to 0, can't have negative radicand. That's what you should be thinking in your head. That's why I'm writing it as like a tip to you as you're doing these problems. This is where Ms. Holcombe would say, oh, you can't have a 0 in the denominator, or you can't have a negative under the radicand. That's stuff that you should be telling yourself. So we need to adjust this because we have two restrictions. Can't have a negative radicand would mean take the radicand and do what with it? Set it greater than or equal to 0. But what's the problem?
It can't be 0. So
There's a second restriction in here that we have to account for at the same time, and that's that we can't actually get 0. So what do I tweak? Yeah, just take that off. Yeah, it's calibrated now to account for both restrictions. Do you notice that? Might want to highlight that in case you have one come up. But this accounts for those two restrictions. It cannot be 0 and it cannot be negative, so therefore it can only stay greater than. So solve it. So I'd subtract 3. And then I would do what? I would flip the sign, and I'm going to draw another little exclamation point, like, watch out, what I just did here. So the domain is any number x as long as it's less than 3. Or in interval notation, if you think about that, that means it's at 3 and it goes to negative infinity. Read it from left to right. So it'd be negative infinity up to 3. What type on the 3? Yeah.
Could you please send Shaylin White to the office for a moment?
She's on her way.
Thank you.
The domain stuff's going to come up several times, so try to keep that fresh in your mind, okay? It doesn't change. It's either fractions can't have 0 on the bottom. It's even roots can't be negative underneath. I think that was it. Doesn't have any restrictions. Because odd roots don't have restrictions. Absolute value doesn't have restrictions. All right, look at this. Compound inequality. Let's see the preview of where we're going. Okay, I think we did this the other day, or, well, a month ago. If I sent you to the store to get me, and I would never do this, but if I said, hey, go get me a Coke or a Sprite, you could come back and hand me what? You could hand me a Coke, you could hand me a Sprite, or you could have said, here's both, I didn't know what you wanted and I had the money, right? By the way, that's what you always do if a female ever gives you a choice. You always just go extra. If he came back with a Coke or a Sprite or both, he's met the requirements of me saying, get me a Coke or a Sprite. If I said, go to the store and get me a Coke and a Sprite, there is only one way you are allowed back, and that's if you have both. There's only one way to meet that satisfaction, right? So the same thing goes with compound inequalities. I can't talk. If it says and, it means that it has to meet this restriction and it has to meet this restriction at the same time. Now we're talking numbers, not Coke and Sprite. We're talking about numbers on a number line. So it'd be like me saying, pick a number less than 3 and greater than 7. That's not possible. You hear what I just said? Pick a number less than 3 and greater than 7. That doesn't exist. So that's what compound inequalities encompasses. We're going to get to, if that was the answer, it'd be no solution, because there's no number that exists that meets that requirement. If I said pick a number less than 5 and greater than 0, there is a number that you can pick, right? Less than 5, greater than 0. There's several numbers in there. So this is where we're going. Now, there's 2 ways to see and inequalities, and that is if it says the word and, or more commonly, you're going to see it written like that. Here's where having a highlighter is helpful. If you need one, let me know. But notice there are 2 inequality signs there. There's 2 inequality signs. You may need one. Those 2 inequality signs that are sandwiching 2x plus 5 in between. Anybody? One over here. That's letting me know that, hey, the expression 2x plus 5 is literally in between the numbers -3 and 7. So you have to visualize that, okay? Now, we don't want to actually run with that and try to graph it. We want to solve it so it's just x is in between 2 numbers, not 2x plus 5. So we're going to solve it right here. We have -3 less than 2x plus 5 less than or equal to 7. When you're reading compound inequalities, read from the middle. Read from the x expression. So like this is the expression for x. So this is saying 2x plus 5 has to stay greater, notice how I'm reading it from the x, greater than -3 and at the same time less than or equal to 7. All right, we're going to solve it by whatever we do to one section, we do to how many sections are there? There's 3 sections. If you need to, you can drop lines here, or you can do highlighters. I don't like it. Hold on. You can do highlighters. It's up to you. Whatever works for you. You don't have to do anything. If you know there's 3 sections. All right. The goal is this by itself. Move to 5 first. I'm going to show all my work because there's 3 sections and I want you to know where my numbers are about to come from. So in the middle I'd be left with 2x. All I did was subtract 5, so I don't need to change any of my signs. -8 over here, 2 over here. Now I need to do what? Divide by 2. So I'm going to divide this, this, and this, and I'm going to double check myself. What I just divided by is positive, so I don't have to worry about any signs. You've just gotten the answer in inequality form. Now what you need to do is write it in interval notation and shade it on a graph. I want you to treat x as the shaded section so that you can visualize where you're shading. This has an x sandwiched between -4 and 1. So I'm shading between -4 and 1. Then you just look at your inequality signs to see if it's open, closed, or bracket parentheses. That's a parentheses, and that's a bracket, and I'm sandwiched between. So there it is as a shaded region. In interval notation, when it's an and inequality like this was, it is the easiest interval notation because you are literally bringing the numbers down and you're just slapping the bracket or the parentheses on it. Alright, let's do a what if, because it's going to come up. It doesn't come up in the notes, so that's why I'm saying that let's make a little blurb over here. You'll notice that the notes are coming from the textbook, which we're supposed to use. And then you go to do the homework, and sometimes some of the homework problems are maybe a little bit more challenging than the notes, or maybe they involved two concepts together, and we didn't actually practice that exact question in the class in our notes, but we practiced the two concepts in a separate fashion. That's college level, okay? Gone are the days where she didn't show it to me in class, so this can't be it. Like, that's gone. You're supposed to be inferring from each of the examples and being able to tie them together at any given time. So be prepared for that. It comes up every now and then. Perfect example, there's no solution example in our notes, but I know it's in the homework, so I wanted to at least show it to you. What would it look like if there was no solution? Well, if at some point during a problem you did divide by a negative, it would switch all the signs, right? The signs would end up looking in the other direction. By the way, they'll never do that. That's kind of your telltale sign something's off. Because it doesn't make sense to read it this way. Because if you read it from the x, this is saying x has to stay greater than our JK, did it backwards. Do it this way. That's what I meant to do. Because they always face this way when it's a compound inequality. I meant to say they don't face this way. So if you read it from x, it's saying x is less than negative 3 and at the same time greater than 5. That doesn't happen. So let me show you what it looks like on a shaded region. You would go to negative 3. This is saying go less than, right? And this would be at 5, and it's saying go greater than. Because it's an and inequality, and means where do the shaded sections overlap? There's no overlap. And it's an and inequality, which means it's no solution. There's no number less than negative 3 and greater than 5. It doesn't exist. So that's what it would look like. If it was an and inequality and you did divide by a negative, the signs would flip in an awkward direction, and then it won't make sense. There's no overlap. Now let's do an or inequality. The good news with or inequalities is they don't have as many restrictions. So go ahead and start this one. You will notice if it's an or inequality, you'll see or. You will actually see the word or. That's how you know. Every time. And you just have two inequalities in one problem. So we have 2x minus 5 is less than or equal to negative 7, or so solve them individually, then put both solution sets on the number line. the sign here? No. Watch out, don't flip it when you don't need to. Remember, it's or, which means you're putting both on there. We're not looking for overlaps. This is less than -1 or equal to it. And this is greater than 3. How many shaded sections do you have? So you're going to have 2 intervals then. And you're going to read them from left to right. So I've got -infinity up to -1. Do you remember what to put in the middle? Union. We practiced that in the review chapter. Okay, just like we did on the other slide. So we looked at what no solution looks like. It's when it's a situation like in terms of an and inequality and you're looking for an overlap and there's no overlap, there's no solution. What does infinite solution look like? It's when the entire number line gets shaded. So, for example, if you had an or inequality and let's say that the coefficient of x was negative and you moved by division, you'd have to do what with the signs? Flip them. So let's say we came to this, and you're just going through the motions, and you're like, okay, I got 2, I'm going to go to my number line, I've got -1 here, I got 3 here, that's a closed, that's an open, now you shade. This says shade greater, this says shade less than. The whole number line ends up getting covered, and that's allowed because it said or. It didn't say and, it said or, which means that's okay. And is the one that's restrictive. And is the overlap. Or fair game, the whole thing. So in that case, it would be infinite solutions because you ended up shading the entire number line. Okay? Which I've just figured out why this had 8 slides and your paper only had so many, or mine, I thought mine only had 6. The next slide is something I added last year to help talk about these special cases, but we already did it with the little what ifs, okay? So this was saying, you know, in this case, there's no solution because this was...
Kristen, can you help me for example?
She's on the way.
Thank you.
So in this case, there's no intersection, which means there's no solution. We already talked about that. All right, go to the word problem. Great. For her interior decorating job, Natalia can be paid in one of 2 ways, either $2.50 plus 10 an hour, or 20 per hour. Suppose the job takes N hours. For what values of N would Plan B be better for her? If they're saying Plan B is better, they're giving you an inequality. What's it saying? B, do terms of B or A. There you go. If they're talking about getting paid and they're saying which one would be better for her, they're implying she would make more money. So when would Plan B generate more money than Plan A? Does that make sense? Now we do need to write the rates at which she is charging as expressions. We already have a variable. I don't know why they didn't use H, but they used N. That's all right. We'll go with N. Think of that cell phone problem. What was the other? There was another problem we did yesterday. There was a rate. The cab. I want you to write this as an expression and write this as an expression. Remember, your hours are the letter N. So A would be what? 250 plus 10N. And what would B be? 20N. And we are literally saying that plan A, no, B is greater than plan A. So plug it in and solve. Right? You know, this is not a bad problem for like if you're gonna start your own little side gig like mowing yards or pressure washing houses or concrete. You can come up with rates so that the customer thinks that they're getting a good deal, but then you could say, well, if the job takes me more than so many hours, then it's going to be this rate, because obviously you just worked more hours than you entailed in the first plan. The first plan takes care of if it's like a small job, but you put a lot of thought, time, and effort into it, but the job itself only took an hour or so, you know what I mean? All right, let's see, B is 20N, 250 plus 10N. Did you get that? What does it mean? Keep going, you're almost there.
Okay. More than 25 hours to make more money. Plan B.
There it is. Be specific. So if she puts in 25 hours or more than 25 hours into the job, it's better for her to charge by plan B. She'll make more money. Or you could be like the guy that pressure washed our house. He just charged by the window. It's not ideal because there's a couple of windows in our house that are double the size. So I'm like, okay, sure, flat rate. You need to be able to say, I think on my math lab they have it as fill in the blank. I don't think it actually has a text box where you type the sentence. I think it would be, she would need to put in more than blank hours to earn more money using blank plan or something like that. Yeah. That's it. I did put this one at the end. So let me remind myself why I put it here. Okay, I think I put this here because it was percents and I wanted you to make sure to pay attention to the percent needs to be in decimal form. It's also saying assuming he makes more than 7,000. Try it and see if you can do it. This is not due till Sunday night because tomorrow's Friday, right?
Yes.
Tomorrow we will do 9.1 and it will be due Monday night. You with me? So Sunday is 1-6 and quiz by Sunday. With me? 5-question quiz and 1-6 by Sunday night. We'll do 9-1 tomorrow, and it's due by Monday night. Tomorrow I'm also going to give you the formula sheet so you already know what's going to be given. I'm going to give you a blank practice test sheet. So you could also start on that over the weekend so you're not cramming it all on Tuesday night, okay? Please don't wait till Tuesday night. In fact, let me just say that a student from last year messaged me this morning and said, hey, how's your classes going? Wanted to tell you I'm in calculus at Dalton State, and I really thought I was going to do great on that first exam. I didn't study, and I had to wake up call. These were his exact words. And then of course he was like, I thought you said we weren't going to use logs, and I was like, no, actually we did do logs in chapter 5, but that's okay. Good to know you were listening. But I said, why didn't you study? He said, I just thought I could do it without studying. Not in college, okay? So make sure you're remembering you leveled up when you entered this class.